I'm going to start today by explaining what machine learning is because it's a tool I want to use, and I think it's important to understand how a certain tool works before using it, to know what tasks it is good for, what tasks it is not good for, and why specifically I want to use this tool for the task of drinking water treatment. So as its name implies, machine learning is a tool that we can use to relate a set of input and output data. So we can learn a relationship without learning an underlying process that causes that relationship to exist. So what machine learning is a way to learn some arbitrary mathematical relationship to map a set of input to output data. So even though I cannot explain to a machine what makes an apple and not a banana, I can nonetheless get the machine to learn an arbitrary mathematical relationship to identify apples and bananas. So let's say I wanted to predict how long it takes an apple to hit the ground if I dropped it from any given height. I could get a stopwatch and drop it from various balconies in my building, assuming my neighbors let me onto their balconies, until I have enough data to plot a graph, and then I can simply draw a line and interpolate for any given height of interest. So that's essentially what machine learning is. It's learning a pattern from a set of data in order to make predictions with a new set of data. But predicting how long it takes an apple to hit the ground can be solved much more easily because there exist already well understood equations that describe the motion of an object falling through the atmosphere. And these equations can easily be explained in terms that a machine can understand. So there is no reason to use machine learning for this type of problem. But now we pass to the problem of coagulation. So in water treatment, coagulation is the process by which we destabilize particles in water so that we can bring them together to form larger flocks and then settle them out via gravity. We have a general idea of why coagulation works, but unlike, say, the motion of falling objects, we don't have specific equations that we can use to accurately determine what dose of coagulant in some sample of water with given parameters will produce what result. And so even to this day, operators control coagulation using the jar test, which is simply a trial and error test of testing different coagulant doses in a water sample to determine which one leads to the best quality of treated water. Because there exist no current equations to optimize coagulation. So this is where machine learning comes in. Like I said earlier, machine learning is a way of relating input and output data without learning the underlying relationship, the underlying process that causes that relationship to exist. And so coagulation is a prime example of a problem that can be addressed with machine learning. Because we have ways of measuring the inputs and outputs to this process, but no understanding of the underlying process, that's fine. And so my research project is to integrate machine learning for process control at water treatment plants, first at the Chomedey water treatment plant in Laval, and then to export this technology to other treatment plants using machine knowledge gained at Chomedey. This aims to reduce operating costs by reducing unnecessary waste of excess coagulant, and it increases resilience and robustness in treatment by giving operators advanced knowledge of how to treat certain waters. Thank you.